All right, well, good evening, everybody. Good to see you. Let me get out of Keynote here so I can get to what I actually wanted to use, which is, I know I may be the only person in the world who uses Google Slides, but I'm going to do that. The description was a little bit odd. That wasn't exactly what I had in mind. I want to talk to you about what's new in Java from 9 and above, but I'll comment on a few things in 8 as well. I'm assuming that most of you have been using Java 8 for a while now. Is that reasonable? Now, I know a lot of people who are using Java 8 just to compile older code. They aren't necessarily using the functional features. So I'll summarize a couple things there. But the real topic of interest these days is what's going to happen when 11 comes out and suddenly we've got a new long-term support release and Oracle's going to start charging for, I'm kidding, Actually, they are going to be charging if you use it in production, okay, if you use the Oracle JDK. But if you use the Open JDK project, that one is always going to be free, okay? And they are supposed to be essentially binary compatible. There may be some minor differences because there's always an edge case here or there, but in general, they're adhering to the same spec, and everything that works on one should work on the other. So if you want to stick with a free production JDK, you'll use the Open JDK project or one of a variety of competitors that are going to be out there. Now, the downside to doing that is that when patches and things like that are released, security updates and fixes like that, then Oracle, of course, is only going to patch Java 11 for 6 months, until 12 comes out, except it's a long-term support release, so if you have the contract, you can use it for 3 full years. It'll be getting their patches that way. The question is, will those get ported over to the Open JDK project? And the answer is probably, but nobody has a definitive answer yet. Actually, I shouldn't say probably, I should say almost certainly. But nobody's willing to step up and say, yes, we're going to do this until Java 11 is released. They want to know the details on this. So this isn't radically different from what we've gone through now. It's just that the pace of change is a lot quicker. And if you want to use Oracle's system, you're going to have to pay for it. If you want to stick with the free version in production, then that's fine, but they're only going to patch the free versions while that version is current. So once 12 comes out, they're going to expect you to move to 12. They're not necessarily going to patch 11 anymore, and 13 and 14, etc. Now, there's a lot of ifs, there's a lot of movement around the fringes, a lot of discussions about what's actually going to happen in practice. This is a capsule summary that the Java Champions group put up a document that goes into great detail about the separate licenses and all the possibilities, and I'm going to recommend you take a look at that. Now, what I'm going to do today is I want to talk to you about what are the new features. So the licensing discussion is something that you'll be making as a decision you'll be making company-wide as to how you want to handle that. The question is, how hard will it be to port my code from Java 8 to 11, if that's going to be the long-term release? And the TLDR answer, the real short answer is going from 8 to 9 can be a challenge, can be reasonable, but can be difficult. Going from 9 to 10, 10 to 11, that's trivial. In fact, 10 to 11 is nothing. I mean, I've been running code that I had running on 10. I just downloaded the early access Open JDK version of 11, and no changes whatsoever were necessary. And actually, from 9 to 10 is almost nothing. The challenge will be the module system, okay? And I'll get to all that. So there's your real capsule summary, but let me talk about what new features have been added. Now, I'm going to send these slides. Is there any way to get rid of some of the light up front or whatever? I don't know, we'll see. But I'm going to send these slides to Vincent, and he can add it to the website when we're done. This is a talk that I normally give on the No Fluff Just Stuff tour, but I'm also going to, as I say, I'll give the slides to Vincent. We can handle it however you like. My name is Ken Kousen. It's Kousen like the relative, even though it doesn't look like it. So my company's Kousen IT Incorporated, or thank you, or as my wife says, Kousen it, It was her idea. At any rate, there's my email address, homepage, blog, Twitter handle. Feel free to contact me whenever you like. I have a couple of books. A few years ago, I wrote a Java Groovy integration book called Making Java Groovy. That's a Manning book. Then in 2016, I wrote a book called Gradle Recipes for Android. That's all about the Gradle build tool for Android applications specifically, but Gradle in general. And that's an O'Reilly book. And then last year, August of 2017, this book came out, the Modern Java Recipes book, and this is the one about streams and lambdas and method references and all of those features. Now, this I'm bringing up not to try to sell it to you, but to tell you that I have a couple of GitHub repositories where I'm going to pull code from. And I've got a new one as well, but I want to mention at least a couple that are on this slide. This one, my GitHub account is under my last name, Kousen. So these are both github.com/Kousen. And one says Java_8_recipes, and one says Java_9_recipes. That's before I knew that putting a number in there was going to be a problem, you know, as it turns out. Now, I'm going to show you some code from the Java 8 recipes one and some from Java 9 recipes one, but the Java 9 recipes one's been updated to Java 10 and 11. Okay, so that's actually running 11 at this point. I just don't know that it's practical to change the name of a repo necessarily. So even though it's got that name, it's running the Java 11, well, 9, 10, and 11 demonstrations that I want to show. Now, the reason I had to keep them separate, however, and this is going to be a key thing that you'll be dealing with, is the module system. Because the way the module system was implemented, you put in a Java file, not a class, called module-info.java. So it actually has a given specific name. It resides in your code base, generally in the root of your hierarchy, just basically in the class path, like source main Java. You'll put it right there. And it has a particular syntax that is used for modularization. The problem, of course, is Java 8 doesn't know from that. And even though they say Java 8 should be able to ignore it, I have not had a lot of success on that. So if I have code that has not been modularized, then I can run on 8, 9, 10, 11 without a problem. In fact, my Java 8 recipes repository I ran today, just to be sure, on Java 11, and everything worked fine without a problem. But as soon as you introduce modules, now you are 9 or above. No question, because you have that file in there that is only understood by the Java 9 compiler and above. So we'll talk more about that, but that's why I have a separate one. I also have an additional one I just added this afternoon. I'll get to that a little bit later. In case you have an account on Safari Books Online, not only are all my books available there, I have a whole bunch of videos there, more than the ones that are listed here. Spring and Reactive Spring, I've got one of those too, and a bunch more. And let's just dive into this now. Now I actually have slides for most of these things, but I thought I'd give you a summary of what sorts of things were added in 9 and 10 and 11 and so on. Now, the big one, of course, the one that's the controversial one, is the Java Platform Module System. They don't like it when I call it this, but I still can't believe they actually called it Java PMS. I'm like, aren't there any women on the team at all? Or are the women there making some kind of ironic statement? I just don't understand it. But at any rate, this is what you hear about when you hear the reference implementation referred to, which is called Jigsaw. So this is the module system. This is the thing that's supposed to be competitive, if you will, with existing module systems like JBoss modules or OSGI or what have you, even though it has nowhere near the capabilities that those do. It's much simpler, much more stripped down. And the short answer I'm going to give you on that is that if you do not have to adopt the module system for your own code, if you're not writing a library, if you're writing a library, that may be different. But if you're simply writing your own application, you do not have to adopt modules anytime soon, and all your code should be fine. As I say, I ran my Java 8 code under Java 11 without any changes whatsoever. As soon as you introduce modules, life's going to get complicated. Now, if you own all the code, again, it's doable because you add these module info files and you add the contents, things like requires and exports and opens, and it's all actually pretty straightforward and pretty clean, and the major IDEs can even help you with it, especially IntelliJ. But at some point, you may add in a library that has not been modularized yet. And then you get mixtures of the module path and the class path, and trying to understand the two together can be an adventure. I went through that recently, and I'm going to show you a little bit of detail about that. Okay, so the short answer is if you can delay the move to modules, you're fine. You shouldn't have to deal with anything. If you're producing a library for other people to consume, you probably shouldn't delay that. You probably are going to want to build a module, and then you'll have to deal with all the remaining issues. But there's no immediate need to go to it unless you're planning to produce a library. Okay, I'll mention JShell as well. That is the REPL, the read, eval, print loop. We have a shell now for Java. And I suppose there's a use case or two where it's helpful, but I haven't really found too many. Generally, I'm fine opening up an IDE or even using something like Atom or VS Code or whatever. Those work fine. I don't necessarily need JShell, but it is there, and I'll show you that it exists. Now, I do want to make a comment about reactive streams. Now, in order to really talk about this, let me go to, I'll use this one. So here is the Java Development Kit, Java Docs for Java 10. And by the way, you can see on this page the one reason you do want to adopt Java 9 or above. They have finally put a search box in the Java Docs. We've only needed that from the beginning, and it's a good one too. Like if I want to go to stream, I mean the stream interface, which is incredibly hard to search on in the regular Java 8 Java Docs because you hit all those I/O streams on the way. Well, now if I put my cursor in here and I just type str, then bang, it already shows me packages, types. There's the type right there, and I'm right there. And that's why, by the way, it no longer defaults to the frame set anymore, because the reason I used to keep it in a frame set was so I could search on the page. And now I've got this nice little search mechanism. In fact, I think you can even search on methods like to_binary string. You see there's integer.toBinary string. So there's a good thing. Okay, and presumably when Java 11 becomes official, which I believe the tentative date is the 28th, so right before the deadline for the Dev Nexus submissions, right before that, then I presume then the Java docs will be updated as well. But right now, this is what we have. This is the Java 10 one. Now, I wanted to mention reactive streams. And if you've ever coded with any reactive library, so that would be if you're a Spring person, we're talking Project Reactor. If you just like RX Java, for example, that's a very popular one. If you come from the Scala world, there's Akka, for example. Then you'll know that they all have their own implementation of some spec out there that's called reactive streams. Reactive streams has been added to Java 9 in the API, and there is a class called flow, or rather, here's the flow class. This is part of java.util.concurrent. Is this big enough? Can you see that? Okay. All right. Now, this is a class that has inner interfaces called publisher, subscriber, subscription, and processor. These interfaces are the interfaces defined by the reactive stream specification. So Java 9 decided to add them to the actual Java API. However, there's no reference implementation of them in the Java API. So it's like, well, why are they there? Well, one is they are showing support for the specification. And another is maybe they'll add one later. But honestly, if you're going to do reactive streams, adopt one of those existing libraries. Okay, go with Project Reactor if you work with Spring, or RxJava 2. I mean, you have to pick the version of the library that supports reactive streams. So Project Reactor, that would be Reactors 3, Reactor version 3, RxJava version 2, Akka, I forget which one it is, but at any rate, they all will discuss that in detail. So I point this out to show that these interfaces are in Java as of 9, but you probably won't care. I mean, you will be using them, but indirectly in general. Now, I expect that 11, 12, 13, they may add some things that will implement these later, but that's probably not something you need right away. Okay, so let me go back to where I was here. Oh, I'll find it. Did I lose my slides? Oh, there they are. Okay, let's move that over here. There we go. All right, now, when we get to private methods and interfaces, now I can actually talk about code in this case. So here is my GitHub repository for Java 8. Okay, so this is Java _8 recipes. And as you may be aware, in Java 8, they introduced the idea of adding default and static methods and interfaces. Now, how's that font size? Is that big enough? Do you see that okay? Do you need another size up? Okay, because the thumbs up, I was unsure whether that means that's good or go up another one. Yeah, okay. All right. Thank you. Any rate, so this is a tiny little interface called company. It has a method called getName, returns a string. In Java 7 or earlier, we would just have an abstract method like this, returns a string. In Java 8 or above, you can actually add the keyword default and then provide an implementation. And that's what this is doing. getName is providing an implementation of initek. Here is an employee interface that has getFirst and getLast as abstract methods, convert caffeine to code, presumably for money if you're an employee, otherwise you're a volunteer, I suppose. And here's also a getName method as a default, and of course it has a different implementation than the other one. This returns getFirst and then a space and then getLast. So I have two interfaces with the same default method signature but different implementations. This is why Java added interfaces in the first place, right? That's why we don't have multiple inheritance, because we get a conflict and we could even get a diamond problem, all of that. So what do you do if you implement both interfaces and get a conflict? Well, here is a class called company employee that implements both, and you can already see the answer, but let me comment it out for a moment. If I implement both interfaces, I get an error, which you can't read, but it says company employee inherits unrelated for defaults for getName from company and employee. Say you got both, I can't do it, I'll just fail. Now the rule is for default methods and interfaces is class versus interface, class wins, period. So if you have the method in a class and there's a default method in the interface, the class overrides, if you will, the interface method. That's easy. If you have two methods, the same method in two interfaces, and they're related by inheritance, well, the child overrides the parent. Again, we're just like in classes. But if they're unrelated by inheritance, as you see, the class will not compile until you implement the method. Now, the implementation can be anything. It can be a no-op or whatever satisfies the contract. It doesn't matter what it is because, again, the class wins, period. However, say you want to implement it and you like the implementation in the default methods, you can access the default method implementations through the super keyword, just like you would in classes. So this says employee.super.getName is working for company.super.getName, and this needs the super name because, again, I'm overriding a getName method anyway. So just like you would use super with classes, now you can use super with interfaces. And that's default methods and interfaces. In fact, that's all you'll ever need to know about default methods and interfaces. That's the whole thing. Now, they've also added static methods to interfaces, and a classic example of that would be a comparator. And if I go to, for example, the comparator interface, this is an interface, as you see, interface comparator. And if I scroll down, you will see that there's an abstract method called compare, and then we get static methods like comparing and on. And as well, if I go below that, here's a default method called reversed, and etc. Now, the reason they didn't add static methods to interfaces at the beginning is that conceptually it's kind of a hard problem. I mean, what does a static method mean? It means I have a method that I can invoke without an object. It's a class level method. What does it mean to be a class level method in an interface that could wind up being implemented by a bunch of classes? So philosophically, it didn't seem like the right model. The problem is if you don't have static methods and interfaces, people start creating utility classes like collections with an S. Because now you need somewhere to put binary search or sort or fill or all those extra methods. By adding static and default methods to interfaces themselves, now we can eliminate the need for so many of those utility classes for example. And there's the motivation. Now, you do not have to implement an interface to invoke a static method. You just call it by the class name. Like I would say, collections, or I'm in comparator. Comparator dot comparing double, and then provide a toDouble function or whatever and get back a comparator. In other words, I would invoke it from the interface name the same way I invoke from the class name. Now, many of you are already familiar with this because this was all in Java 8 and you may have been using it for years. What's different about Java 9 is that now you can actually put private methods in interfaces. And it's like, wait a minute, why would I ever want a private method in an interface? Because here's the quirky part. If you are in a class and you implement an interface and there's a private method in it, you can't even call it from the class. It can only be invoked from within that interface, which is like, why would I ever need that? Well, here's an example. This is the Java 9 recipes repository. And here what I have is there's a class called private demo implementing some numbers. I don't even need it, honestly. Here is the interface. Now, I have a method called add evens, which is a default method that takes a collection of even numbers, a var list of evens, and it adds them up. I also have add odds, which would do the same thing. Now, in principle, this would be basically the same implementation, just with a different filter. So down here is an add method that takes a predicate. Predicate's one of those functional interfaces added in Java 8, takes a single argument, returns a Boolean. So this lets me make a stream of the values, filter them by the provided predicate, and then add them up, like this. And all I need to do for add evens and add odds is to supply a predicate. I can write the predicate right in here, like this is for each n. It's true if, or return n mod 2 equals not equal to 0. So that's true or false. For odds, I want it not equal to 0. For evens, I want it equal to 0. I can even make that a constant. You've always been able to have constants in interfaces. So I can provide a constant that clients can use. There's my evens one, if you will. And when they invoke add evens or add odds, all they do is provide the collection of numbers. Now, normally I would have made that public too and let the client supply whatever their predicate is. But in principle, just for demonstration purposes, I can make that private, and then it can only be invoked by the default methods in the same interface. So it's an edge case. And that's one of the lessons I want to tell you about Java 9. Java 9 is mostly made up of, hey, we forgot this edge case, or, you know, maybe it would be nice to fill in this little gap over here. It's nothing major other than the platform module system. Other than Jigsaw and arguably JShell, there really isn't that much in it that's going to change the way you code. There are lots of extra methods and added things, but mostly they fit in this category of, oh, wouldn't it be nice if, kind of thing, or it wasn't ready in time for Java 8 type of deal. Okay, so that's static and default methods interfaces, and now, of course, private methods and interfaces as well. So let's go here. All right, now try with resources. Let me move on first of all. Let's talk briefly about the platform module system. Now, there are entire books written about this, and that's a good thing because you're going to need them. But again, as a reminder, you do not have to adopt this for your own code. It's important for library developers, but for your own code, you could safely ignore a lot of what's going on here. Now, there are a couple of links. Now, this is for some reason they're taking their time updating this, but the project itself is hosted at the OpenJDK project. So if you just Google OpenJDK and JPMS, it'll take you to the spec page. I have a link here to the quick start and to SOTM, which is short for State of the Module System. Again, they're taking their time on updating those, but there's your free resource. Okay, there are books coming out and already out on this. The idea, oh sorry, before I leave that, the idea is to add a file with this name, module-info.java, and that goes in the class path, and most people have settled on putting it in the root of the class path in a normal Java project that's usually source main Java. Now, inside that file, we're going to declare our module. I'll show you that in a moment. For the name of that, people do seem to have settled on a standard, which is to use the same reverse DNS that we've been using for packages for years. So, org.ajug.mylibrary or something. Now that sounds like a package name. Think of a module as a collection of packages. That's really the goal. It's to put a bunch of packages together. That's the good news. I mean, the really good news is that once the JVM became modularized, and it has, in principle, you could make a smaller version of the JVM that only has the modules you need in it. And if you didn't need the Corba module, and if you do, my condolences, if you didn't need, the applet module, you could leave those out and therefore reduce the size. Now, for many, many years, size and speed was not something Java cared that much about, but with the rise of microservices again and cloud platforms that charge by disk space and memory, suddenly that's becoming important again. So it's nice to be able to leave things out. Well, that's the good side. The downside is they have changed what the words public and private mean. I mean, it's that fundamental a change to Java. If you are trying to access a public class that's in a different module, you can't see it unless they export it. Unless that module says exports and your module says requires, you can't use it. Now there's some intermediate versions like opens, which allows you to do reflection. But if you're not doing that, if you're just trying to call a class in another module, even if it's public, you can't see it unless it's been exported and you have required it. So they use the keyword requires to specify which module you want. And again, that'll be a collection of packages, if you will. And exports will say what packages you are providing to clients. Now, the JVM has been modularized, and there is a default module, just like there was a default package. Java.lang was always available to us. Well, for modules, Java.base is always available to us as a module. There's a bunch of other keywords. Again, I don't want to take too much time to talk about this. Opens instead of requires, open something for reflection. You can open a module or individual packages within a module. You can use the static keyword to mean this is required at compile time, not at runtime. There's some fine gradations. There is no versioning mechanism built into this, like OSGI has. There's nothing like that. So it's something. It's not bad, again, if you own all the code. The problem is if you don't. Now, if I go to that Java 9 one again, just as a quick demo, I have a module here called client and a module called server. And here is my server module, which has source main Java. Here's module info. Module-info.java. The module name, I called it com.o'reilly.suppliers. And again, it looks like a package name, and that is what people are using. I only have one package inside it. I'm exporting that. Here is my client package, source main Java. This one requires that. So now, and notice this is in clients. So here's my actual client. My client here needs this name supplier. All I have is a little main method. I'm going to call get, and I'm just going to iterate over the names that come out of it. And this, again, comes from the name supplier. Now, say I went to the client module and I didn't have this requires in there. Over here, I get this name supplier. Well, it's not showing up well on the screen, but it's in red now. And it says package com.o'reilly.suppliers is declared in module com.o'reilly.suppliers, but module com.cousenit.clients does not read it. So you do what you always do in IntelliJ, Alt-Enter. Come on. And it says add requires to the module info, and I go yes, and the problem goes away, and you'll see that, in fact, it basically put in the line I took out. It's easy if you own all the code, okay? Now, if I look under external libraries and I look at, this is Java 11 as it turns out. Again, I've moved this up to 11. This is, by the way, for your information, Java 11 Early Access 28-Open. It's from the OpenJDK project. Notice how they have modularized all of Java. There's java.base. If I was to open java.base, these are now packages, java.compiler, java.naming, java.net.http, java.rmi, all these different modules in there. Now the nice thing is I could go into one of them like Java SE and open the module info file, and of course this is decompiled, but you can see examples of how they're using it. This requires all these modules and apparently doesn't export anything. Or how about java.sql? That's a good one. So java.sql requires transitive logging and transactions XA and XML, and exports java.sql, javax.sql, uses java.sql.driver. You can specify an individual class. So really, that's all there is to it. The rest of it is learning the syntax for the various module info files. You don't have to change your code in any fundamental way. It's all an organizational mechanism. Okay, and it can be good, and some people love it. My friend Venkat Subramaniam, who I know many of you are familiar with, he thinks this is phenomenal because it gives you true encapsulation. You can't just get around Java's security mechanisms by using reflection, for example. If it's not exported or open, you can't see it. I personally don't think that, I think this is too high a cost for playing with the fundamental nature of public and private. I think that's causing a lot of problems. Now, here's the good news. If you own the code and can simply add these files and modify them as you need, you're fine. The bad news is, what about libraries that have not been modularized, that don't have a moduleinfo.java? Well, they become part of what's known as the unnamed module. There's a name for you. Or they can be an automatic module. They can reserve a name if they want, even though they haven't implemented it yet. But if they're in the unnamed module, the name of the module becomes the name of the jar file, which of course is not stable, right? They could release a new jar file with a version number in it and they broke everything. And now you're mixing class path and module path together. And that's just so much fun. Okay, so that's where the challenge will be. If you can delay long enough that all of the libraries you need have been modularized, your life will be easier, but that may be a long wait. Okay, so that's all I want to say today about the platform module system. Here, okay.
So what you're saying is it's not a requirement to use this feature.
That's right. You do not have to use this feature. Now the library uses it, but that doesn't hurt anything. Here's what happened, okay? I did a nice little example. In fact, in this, why don't I mention it now? This is my Java 9 repository. And I put in that client module and the server module and thought everything was fine. And then I went into my regular part, the regular source main Java distribution. And then I decided to add a module info.java file and wound up with chaos. Until I added this module, everything worked just fine. But I decided to use Google's JSON or another module. And it turns out this is the guy that was the problem, is that JSON, a very, one of the most common JSON to Java converters ever, has not been modularized. And therefore, I couldn't import it until I found out what the name of the actual jar file was, even though in my Gradle build file, I had added the dependency right here. See, there's my JSON dependency, and yet my IDE couldn't see it, Gradle couldn't see it, nobody could work with it at all. When I finally found out that the name of the module was JSON, I was able to require it, but then all my tests failed because Gradle wasn't able to tell the tests, which are in a different section, different source code, they're under source test Java hierarchy rather than source main Java. The tests couldn't see the main distribution. And eventually what I wound up having to do was this mess down here. I had to add compile Java and create a module. So this module name, by the way, I got this information from Gradle. So I made a module name for my own class. Now this is what happens when you want to produce your own module. Now again, before I modularized my code, I didn't need any of this. But as soon as I added the module info.java file, I had to create a module. This lets me create a module. It says before you compile Java, add this compiler argument module path to be the full class path and clear out the class path because I don't want the class path. And if I want to do testing, then I need to set the module path to the class path. I needed to add my JUnit 5 module. I need to say that JUnit 5 reads my module. See, I had to export my module to JUnit 5 and then do this patch. It was a mess. Yes, sir.
That looks really hard, and
Yeah.
I'm wondering what the advantage of doing this is over just containerizing whatever you call a module.
The question was, what are the advantages of doing this over just containerizing the modules? Nothing, okay, in my opinion. Although, by making a module, now I can choose what to export and what not to. In other words, it's the advantages associated with modules in terms of encapsulation and only requiring the parts I need. They have a tool called JLink, which will let you figure out only the modules you need and then they'll create a JRE that only has those modules in it, that sort of thing. So if you want to do that, great. Otherwise, you package in the entire JVM and all your libraries and you just go the way we've been going all along. And as you say, you could containerize all that and that's fine as long as you got the RAM and the disk space to support it. Okay? So again, until I added that module info.java file, I didn't have to do any of this. Of course, now that I know this, this is the CAP design pattern. You ever heard of the CAP design pattern? It stands for copy and paste. You know, it's how you take an error, one part of your code, and distribute it throughout the whole system. Yeah. At any rate, now I know how to do it, and I gotta believe this is going to get easier. The Gradle people say they have an experimental Jigsaw plugin, and hopefully that will simplify this. The Maven people are working on some surefire plugin to make the testing part easier. We'll see how that evolves over time. But I just wanted to give you an idea of the sorts of problems that can come up once you go and modularize your own code. But as I say, on my Java 8 repository, I haven't modularized at all. Everything works under Java 11. No change whatsoever. Okay?
80% of the people out there, this is mainly targeted for companies to distribute shrunk down JVM components.
I don't think of it that way. You say, again, for the video, that the question was, is this targeted for companies to produce shrunk down JVMs and everything? I think it's more a question of library developers modularizing their libraries so you could just use the piece of it that you happen to need in any given particular application. So instead of having to bring in, well, like the JVM's a classic example. Instead of having to bring in the whole JVM, you could bring in a piece of it. Now, I don't know that people are going to cut down the JVM because I can just see compatibility problems coming out of that all the time. But on a regular library, you may, in fact, find it useful to break it into modules and then people will only bring in the pieces they want. Now, most of the books talk about applications being modularized, and you could do the same thing there. Again, I'm not sure that the use case warrants that, but that's just me and I could be wrong. I've been wrong plenty of times, you know. But that's my thought. I don't think it's all about making the JVM smaller. I think it's about getting true encapsulation on smaller pieces of an application. Okay? But again, that's my opinion. Your mileage may vary. That's fine. Okay, now back to what we have. JShell is an interpreter. They have a nice little page here to show you how to use it. Let me copy this link. And then let me go over here. This is fine. Let's make this bigger. And you could see, actually I made that a little big here. You start up JShell by using a command called, do they show it? Yep. JShell. Okay, that's about it. And then you can put in little snippets like you could say, int x equals 45, and now you've created a variable. And you could actually, notice no semicolons in there, yay, you know. You could just put in an expression, it'll make up a variable, call it starts at $1, becomes $1, $2, $3, etc. You can use that as the result. You could say then x plus $1. You could work through this however you like. In fact, just to show you a quick demo here, let me magnify this so you can see it. Just 1 second. That's Java 8. So let me jump to, what the heck, 11. All right. And then I'll say JShell. I have my own script for that, by the way. And you see there I'm in a shell now. Let's move that up to the top. And I could do /help, and you could get information. and notice everything's got a forward slash in front of it because the classic question is how the heck do I get out? That's the old VI joke, right? I've been a VI user for 3 years, mostly because I can't figure out how to get out, Notice exit has a slash exit. Okay, forward slash exit to get out. I always look for that now. But you can open a file, you could save things to a file, you could do imports. There's a bunch of imports that happen automatically. Imports here. All of these packages are imported. You can add additional imports. You could add additional modules. You could save the discussion to a file. I can go 2 + 3, and see there's $1 is 5. I can go $1, -4 or something, and I've got another expression I can assign to a variable is $2 × 8 or something, and go on. I can, as you saw over here as well, I can put in methods. I could write them out. Be careful, they're hard to edit. And, it's a REPL, and Java now has a REPL. Oh boy. You don't need a main method. You're just executing. What's the use case? I don't feel like firing up IntelliJ and putting in a class with a main method. I don't know. That's about it. I don't find a lot of usefulness here. Now, you can even set this to have an external editor and then use an external editor with it. And it's like, now you've really killed the reason you didn't start up your IDE, I suppose. But there's a lot of stuff here, and I really shouldn't be criticizing because a lot of other languages love REPLs. Groovy has an excellent REPL. Scala has a great one. Clojure lives on its REPL. Clojure's, they use that all the time. Even Kotlin has a very solid REPL as well. Well, now Java has one as well. So you can find out variables and methods and list the code you've entered in. There's your imports as well. There's tab completion, which isn't working on my machine, but that's different. There's editing, in the shell, and input line navigation, etc. If you find a really cool use case for this, let me know. I'm curious. So, at any rate, that's available. If you decide you want to use it, let me remember /exit. And I'm out. By the way, for the smug Emacs people who like the VI joke, the corresponding Emacs joke is that Emacs is a wonderful operating system lacking only a decent editor. Yeah, so just your mileage may vary. Any rate, okay, back to the slides there. This document that I have linked in here, the JShell information, is actually a pretty good tutorial, and you can learn pretty much everything you need just from that tutorial. It's not that complicated. It is actually pretty useful for very quick and easy snippets of Java, just testing things out. My problem is I don't write Java a line at a time or a method at a time. I write classes, and it doesn't really suit that sort of mechanism for editing.
I have a question.
Yes, sir.
If you go to Groovy shell, for example.
Yeah.
So let's say I type something, I test everything, I'm happy. And with Groovy, you can say Groovy -e and pass in a bunch of things and
Yes.
work for you. It's great when you're trying to script your way in the middle of a script.
Right.
Can you say JShell -e, whatever?
Can you execute a file using the JShell command? No, unfortunately. However, and yes, Groovy allows you to execute a script both with the script by itself or using the -e command where you embed it on the file. Kotlin has something similar, they all do. But Java does not. However, that reminds me of one thing I have to show you. This is the big addition to Java 11, okay? I mean, between 10 and 11, there's almost nothing that isn't under the hood. There's a lot of stuff under the hood. Here's the big addition in Java 11. Where's my shell here? Yeah, okay. No, here. I have a Hello World program as Java. Up until 11, I would have to compile that in order to run it. In Java 11, I can now run the source code on a one-class executable. That's it. Yeah. Sweet, right? Oh boy, I want to adopt Java 11 now. At any rate, they call this, and it was in my outline, by the way. Let me go back for a second. Launch single file source code programs. That's what that is. If you have a class that has a main method and that's it, or just one class, you can now launch that from the command line without compiling it. Yay. All right, moving on.
If it has any dependencies, though, it
I don't believe so. I haven't done too many experiments about what dependencies you can get away with and what you can't. I believe maybe if everything's all in one file, you might get away with it. But if you're going to do that, just compile the stupid thing. You know what I mean? Why are we doing that? Okay, somebody liked it probably from Groovy or Kotlin or Scala or Clojure. Or, I don't know.
If you don't have JDK installed, does it still work? If you only have JIs installed, does it still work?
No, because the Java command came with my, are you saying if I only have the JRE? You know what, I think so, but I don't know. I haven't tried that. That's a good question. The question for the video was is if you don't have the JDK installed, if you only have the JRE installed, so you have the Java command, would this work anyway? I suspect it will, but I don't know how. So I haven't actually tried that. I'll have to try it and let you know. Good question. I don't know why that didn't occur to me. At any rate. Okay, now on to stuff that's actually pretty good. In Java 9, they've added what they call collection factory methods. List.of, set.of, map.of. If you looked at Java 8's API, you notice they love the word of, OF, as a static factory method. It's a static method, always called from the class name, and it produces an object somehow. So this is used all over, optional.of or a stream.of. There's a lot of methods in the Java 8 API. In Java 9, they have added that to these interfaces. See, it's a static method in list, set, and map. And I want to talk to you about it for a moment. So let me go back to my API here. I can't find it, so let's do that. Docs. If I go to, let's say, list. So here's java.util.list. And I'll scroll down. Here they call it the section unmodifiable lists. Now, originally they called these immutable lists, but it's not really immutable, right? I mean, what they mean is you can't add or remove elements from this list. You cannot modify the list, but you can modify the objects in the list if they are mutable. You know what I mean? So if I add a bunch of strings to it, yeah, it's all immutable. But if I added person objects, I could get a reference to an individual person and change their name or something. Is it an immutable list or not? Well, it's an existential question. They decided now to call these unmodifiable lists. If I tried to modify it, they are unsupported operations. Now, they disallow nulls. You can't put a null in one of these unmodifiable lists. They're serializable. If the elements are serializable, they keep them in the same insertion order that they use. And here's the factory methods, and you want to see some overloads? Here's of with no elements, which is kind of useless for a list that can't be added to, right? But so be it. Here's one element. Here's var args. But here's 2, 3, 4, 5, 6, 7, 8, 9, 10. All overloads there. For list.of, there's also set.of and map.of, as you might expect. Now, the default implementation here is not exactly an array list, it's an unmodifiable array list. So they have their own inner class, which makes unsupported operation exceptions for the modification methods. But hey, if you need to create a list, you don't have to instantiate one anymore and call add. You've got factory methods for lists, sets, and maps. Now, there's one little interesting quirk here. Oh, I went the wrong way, didn't I? That ought to freak everybody out. Let's try this again. So here in my collections, actually I think it's better in the test case. I have this one as a better test case. So down here is a list.of, and I'm putting in URLs for the individual languages, Java, Groovy, Scala, Clojure, Kotlin, etc. And here is a set.of, which is putting in the language names. And the set.of, I believe, throws an exception if you do a duplicate, because they really are trying to make something immutable, well, unmodifiable. Okay, but it's a regular old set, same contract as for sets. Now for map.of, you have two ways of doing it. Here's one. Map.of, you put key, comma, value, comma, key, comma, value, comma, key, comma, value. So you could build them in one by one, which looks really ugly, no matter how nicely you try to format it. So instead, what they also did is they added a method called of entries to map, and then they added a static method called entry to map that lets you put in key, comma, value. And you can do of entries with these entries in there. And if I do static imports, I could even make that very, very clean. So nice. The only downside, again, is that they are unmodifiable. That may affect when you can use them or not. Okay, you can use them as the argument to a modifiable list if you want, but regardless, they're now factory methods inside of Java, starting in Java 9. So that's available. You might find that useful. Private methods we talked about. Both default and static have been there since 8, private methods in 9. I told you about the reactive stream stuff. There's a process API added in Java 9. I didn't put much in it because I don't generally use it, but there's a class called java.lang.process that can get information about process IDs and start time and accumulated CPU time only on processes you spawn, okay, from there. But you can get information on it. I have a friend who used it who really liked it. I don't have any examples of it. I haven't used it, but it's available. Okay? See what I mean about edge cases, though? Try with resources. I have a classic example of try with resources that I have to explain. And actually, the easiest way to explain this is to look in the Java docs themselves under the safe var args annotation. You ever use the safe var args annotation? This is one of those that if you don't have somebody tell you about it, you may never encounter it, because the warning that you get if you don't use it is only a warning. So it's not going to make you use it, but it's a warning that has seemingly nothing to do with the actual problem. Let me scroll down. You see this little method here? They just called it M. And it took a var arg list. See, there's ... and they said it took a list of string ... Now, if you know about Java's var args lists, then you know that what happens is, of course, is that the type is erased at compile time, and that at runtime inside this method, this just shows up as object array, because they don't know what the type is. ... becomes array, but they don't know what the type is. So you could, in principle, do this. You could say, all right, I'll take my argument here, and I'll assign it to an object array. And then I'm going to do this horrible thing. I'm going to make another list that holds an integer. So there's a list of integer, and I can go and replace element 0 in the object array, which is supposed to be an array of list of string, and put in an array, a list of integer instead. And the problem is when you call get on that, then you get a class cast exception, because there's no way for the compiler to prevent that. Because as far as the compiler is concerned, the type's been erased. It can't check you. So if you leave out the last line, which is going to throw the exception, if you simply write this code, it compiles with a warning that says heap access, unsecure heap access, or not unsecure. It's called possible heap pollution. Seriously. Now, does that tell you anything? Possible heap pollution. And what they want you to do is they want to say, put @safe var args on the method, because that's your way of saying, I promise I didn't do that. That's it. That's safe var args. Okay? And safe var args is an annotation that was added in Java 7, actually, and that's its purpose. It's to assure the compiler that you know what you're doing, you didn't actually or intentionally corrupt a var arg collection. Okay? Good luck with that one. You may go a long time in your career before you encounter that. I sure did. I had no idea. But at any rate, that's safe var args. And in Java 9, I was try with resources. I'll get back to safe var args. They added, you can add that annotation even to private methods now. So it's like it's been around for a while. They added to additional methods. Now, you ever use try with resources? Try with resources also was added in Java 1.7, and the idea is in the try block, you now put parentheses and instantiate a variable, and that guarantees that when the try block completes, the variable will be closed. But this is only if the class implements the auto-closable interface, which means it has a close method. Okay, so for files now you call close. In fact, for Java 8 streams implement auto-closable. So if you create a stream, you can use this. Now here is my Java 8 repo, and here is a nice little example. Yeah, okay. And this will be our quick and dirty summary of the Java 8 changes as well. If you use any Unix system that ultimately has as its ancestor BSD, years and years and years ago, and a Mac qualifies. Then, under the directory user share dict, there is a word list that contains all the words from Webster's Second International Dictionary, copyright 1938. The copyright has expired. They gave us a word list, all 238,000 words in there. It's a great source of data. Okay? So now, and by the way the word list is organized, there's no definitions, it's just words, one word per line. So you don't have to parse the line either, looking for words, it's one word per line, and they're all in there. This class is there in order to find the 10 longest words in the dictionary. That's the idea, using the stream approach. So I have this method called print 10 longest words, and here's my try with resources block. See my parentheses here before the open brace. I use files.lines, that's the new IO that takes a path and will open this and will return a stream of string where each line is one element of the stream. And again, that's one word on each one. Now, in case you're thinking, I don't use new IO, the same lines method is in buffered reader. Okay? So you could use buffered reader if you want to. But the important thing is I'm opening it in try with resources, because by opening it at here, when I finish the try block, Java will automatically call close on the stream, which will then call close on the source and close the file. Most streams are done in memory. You don't care about this, but this one's on a file, and therefore I can close it by using try with resources. Now, I added a filter. A predicate, s arrow s.length greater than 20. I happen to know that the longest words in the dictionary are length 24, so I'm going to sort these things. I decided I wanted to sort them by length, and if I'm going to sort them by length, to get the 10 longest words, I don't want to sort 238,000 words, so I filtered out all but the ones that are length 21 through 24, okay, greater than 20. Now here is a static method in the comparator interface. Comparing int takes a function. Now, a function is another of those functional interfaces where we get one type coming in and one value coming out, possibly of a different type. In this case, I'm using the method reference syntax to invoke the length method on each string. So this function here converts each string to an integer, the length. The comparing method, or in this case comparing int, produces a comparator that compares by some integer value. In this case, it's going to be comparing by length, but unfortunately that would be ascending, so this is a default method in comparator that reverses it. It flips the sign. So now they're comparing by int in descending order. See how easy that is to write though now because of the static and default methods in the interface. So there is a method on stream called sorted, not sort from collections. This is sorted, and sorted will take a comparator and will produce a new stream and sort all the elements by the comparator. So this stuff inside here was all about producing a comparator that compares by length in descending order, and this produces the new stream by sorting it. Now on this comparator, there's also a neat little method, a default method in comparator called then comparing. So in fact, if I was comparing golfers, I could compare by score, then comparing by last name, then comparing by first name, and it builds the whole comparator for me so that equal score, scores are sorted by score, and then equal scores by last name, and equal score and last name by first name, etc. Becomes very easy to write that too. But all I've got is strings, and they're already alphabetical because I'm sorting a dictionary. You know what I mean? So I want to sort them by length, and then equal lengths, I'll leave them alphabetical. But I could have done reverse order if I wanted them reverse alphabetical for some reason. I limit it to 10. I only want the 10 longest ones. And then for each word, I will print out the word and its length. And if I execute this class, I got a main method in here, then you'll see that they'll pop out. And here are my 10 longest words: formaldehyde, sulfoxylate, pathologico, psychological. I see there's 5 words of length 24. Here's the scary one: blepharosphincterectomy. It has to do with the eyelid, so it's gross, but it could have been worse. Okay? But at any rate, you see how this little use of streams and static and default methods. This is the paradigm they would like us to use to work with collections now. And even better, in principle, once you have a stream, you can make it parallel just by invoking the parallel method on it. Now, you don't want to parallelize this. Sorting is stateful. You don't want to do anything stateful in parallel. The Java parallelization algorithm, the Java sorting algorithm already splits things into pieces for you. You know what I mean? It's a modified merge sort or something like that. You don't want to do a parallel on that. But at least with streams, you have the option. For your information, here, if I want to know the words of each length, here again, I open the stream. This time I do a collect with collectors.grouping by length. Grouping by will create a map. The keys will be the lengths. That's this function here is producing lengths. And the values will be the list of strings of each length. So by doing just filter by my size again, collect grouping by length, I now have a map of integer to list of string. For each one I'll print it, and then there are the lengths and there are the words of each length like that. See how easy that became? They did a group by. Now let's be honest, if you do a group by in a database, do the group by in the database, okay? But if the data is coming from a file or it's cached or something like that, Java now has methods for this. Now this is a collector. Here is what they call a downstream collector. I have grouping by again, same thing, grouping by length, but I added in what's called collectors.counting as a downstream collector. That processes the list for each element. So instead of getting back integer comma list of string, I get integer comma long. In other words, this is how many words there are of each length. And that's a downstream collector. And if you use that and you follow all this, you've got the Java 8 stuff. Okay, I mean, that kind of puts together a whole bunch of the concepts we were talking about all together on there. So this is all in my Java 8 repository. You're welcome to it. And then just for the sake of argument, down at the bottom, I used buffered reader as well with the lines method. Because again, it is available if you want to. Now, back to the slides, the try with resources restriction in Java 7 and 8 was that you could only close what you opened in those parentheses. You couldn't pass in a variable and then just put it in parentheses after the try keyword. Now you can. Starting in Java 9, you can use a local variable as an argument to try with resources. It's an edge case, as I say. So, all right, there's that. Diamond operator. If you declare a list of string, you can instantiate a list by itself by just saying new array list and then open, less than, greater than. Put the angle brackets next to each other. And of course the type is inferred from the collection. Well, if you wanted to actually implement this using an anonymous inner class or something, that would require the type inside the diamond operator. Even in Java 8. In Java 9, it doesn't. They figured out the type again from the left-hand side. So again, another edge case. So this is 9 and above. You can now do this. Okay, there's a deprecated annotation for the JDK now. They are actually removing things from the JDK. This is going to cause widespread problems. Even if you don't modularize your code, one of the biggest things happening in Java 11 is they have removed some modules from Java. And the one that's going to get you is the so-called java.ee module, a collection of packages that they associate with Enterprise Edition rather than Standard Edition, and the one that's going to get you out of that is the XML modules. The XML packages are gone. Now that doesn't mean you can't get them back. It means you have to add them back in your build tool. You have to add javax.xml.bind and associated packages, activation, a handful of others. And you will encounter this when you use Spring Framework, for example, until Spring gets rid of the need for those, but I doubt they will. So whenever you use a third-party library that uses any of these, even if you don't do any XML at all, it's going to come up and you're going to need to add a handful of packages to your build tool. Both Maven or Gradle will have ways for you to do this. In Gradle, it's nice. I actually have a build file where I say if the Java version is greater than 8, add the following dependencies. And if not, I can leave them out. So, but that's going to impact you. Now, the deprecated annotation has been added, and it has a couple of properties for removal, which is either true or false. It'll tell you whether it's going to come out or not. And since says which version it's been deprecated since or when it's going to come out. For example, another thing that's now gone, which is sad, is the applet package. Is gone in Java 11. I mean, that was my entry into Java, like so many people. I wrote applets way back in the day, and I actually had a chance to look at some of that code about 6 months ago and recoil in horror. I mean, if you haven't learned anything in 18, 20 years, then you've got a problem. But it's still compiled, by the way, under Java 10, although I had to add in the extra modules. Actually, it was still there in Java 10. They were coming out in 11. But you can look in the docs here. If I go to, for example, applet, here is the module for applet, and oh, I thought it was going to say it. All right, well, let me go to the class and one of the interfaces. There, see, at deprecated since 9. And it's actually coming out. And I imagine when the 11 Java docs are produced, this is still the 10 Java docs, it'll say gone, or it may not even be in here at all. Okay, so we have that available now too. All right, another one. I told you about safe var args. Now you could add that almost anywhere. Before it was kind of restricted to public methods, but now you could put it on private methods and other places too. Okay, now Java 10. The big addition in Java 10, which is not much, was LVTI, local variable type inference. Now we actually have a var. And I don't want to call it a keyword because it's not a keyword. It actually has a word. They call it a reserved type name. You could use the reserved type name var in your code for local variables only, nothing on attributes, nothing on arguments to methods, only local variables, no return types of type var. But if you do, then it'll figure out what the type of the variable is from what you assign it to on the right-hand side. Yay. I mean, that's it. Can you see any potential for problems? I sure can't. Yeah, right. LVTI. Where's my, here it is. Here's my example. So I could go var s equals and assign it to a string and then check, yep, I got a string. That's good. I could do this with a number. I can assign it to list.of, and of course I don't want to get the actual class name because I don't know the actual class name. It's some inner class that they created unmodifiable, but it is an instance of list. So I could just use var like this. What else can I do with it? Not a whole lot else. I just tried doing various variations. Then I decided to cause trouble, so I made a class called var with an attribute called var. And there's my constructor that takes it, and I have my little test here that says, don't do this. And I made var equals new var. And it all compiled and it ran, but again, don't do that, you know. But that's it. It's a local variable, and it's not a keyword, because if they made it a keyword, you're going to break code all over the place. Lots of people have used the keyword var, or used the variable name var. So instead, they made it a reserved type name, and it's only good for local variables. Now, when is this helpful? Remember that try with resources block, or say you're doing some kind of loop and you're working with a map of string, comma, list of integer, or something like that, and you want to declare a variable and you got this huge, massive, ugly type with generics in it. Now you can just go var in a for loop and it'll figure out the type. Okay, I guess that could be good. It does clean up the code. They do have, I think I put a list, here, this is a link to a style guide as to when this is a good idea to use and when not. I've heard very mixed things. Some people think this is awesome. Some people are horrified. You know, that was it. That's the big addition to Java 10, by the way. All right. Yeah, again, no fields, no parameters on methods, no return types. You can use it on for loops and try with resources blocks, which will shorten your code a little bit. Okay. I put this in when Java was still in 9 or 10. They were adding an HTTP2 client library right into Java. And they did that, and I put it in the book. Well, no, I didn't put it in the book, but I used it in Java 10, and it was considered an incubating module. And every time I built using it, I got a warning about it. In Java 11, it's actually in there, and I have a quick example I could show you. Then I'll do the miscellaneous stuff, and then you can ask whatever questions you like. Now, I have some examples, but I have one more repository that I just made, astronomy. Now, what is this about? Here is this one. There we go. This is a site called Open Notify, which provides a JSON response. It's hardly worth calling it a RESTful web service because it's just a link, and you can provide a GET request, and it'll tell you the current locations of the International Space Station or what time it's going to pass over, or this one, which is the number of people in outer space at any given moment. And if I click on this, you'll see the response is a message success, hopefully. People is an array with elements craft and name, and at the bottom here they say number as to how many people are in space. There's 6 there. Okay, so it's a trivial little RESTful web service that I can provide a GET request to. Now what I want to show you is a simple implementation of this. Now let me go to my master branch actually. Okay. So this is going to show you how you can use this, this builder. Now, they have a class called HTTP client, and it has a builder pattern. So I'll say new builder, and you could specify which version of HTTP you're using. I think the HTTP 2 may be the default. You could specify a connection timeout using java.timesDuration, you know, how long, and eventually you build it. There's a handful of other methods you could do as well. Then I could build the request. There's the URL. Again, I make a builder. I call create on it in URI to build that. And then the methods are get, post, put, and delete. And they have mechanisms for all those things, and I build it. So the thing is you could do this synchronously or asynchronously. And the synchronous one, I'm going to call send off the client with that request. That method to build it builds the request. And my response, I'm going to say in the body, just give me back a string. I just want to see the string out of it, and then I could get response.status if I want to know the status code. There's a bunch of methods on that. I just said return the body. Now, if you want to do it asynchronously, then send async returns a Java 8 completable future. So you could chain methods on it like then apply, which means get the body out after it's returned. And then I call get, which is wait for it to come back. Okay, ultimately I have to ask for it on this. So it's a step along the way to reactive, if you will. Now my test class here has a client.getSync and printed and both synchronous and asynchronous. And if I execute this, you'll see there's my JSON data, message success, people is collection of craft ISS and all these names, and there are 6 people on the space station at the moment. Okay? And that's all well and good. And then what I did is I switched to using Google's JSON. And in this one, I did not add a moduleinfo.java file, so everything was easy. Okay, I didn't modularize it. In fact, in my Gradle build file here, all I did was add Google's JSON. And I'm doing some Java 5 tests on this. JUnit 5 test, pardon me. JUnit 5, by the way, is really nice. It's very impressive what they've done with it, and it's extremely well documented. Any rate, in order to break down the JSON structure, I made a response class that has the message and the number and a list of what I called assignment, and an assignment is name and craft. So that's the whole JSON structure. So this time in my client, everything here is the same, except this time when I get back the JSON data, I passed it to JSON's from JSON method and gave it the response class. So all I did was basically add that one line, say, here I built these classes that map to the JSON structure, here's the JSON string, parse it for me, and now my test looks different this time. I can do, here's a cool little JUnit 5 thing, assert timeout preemptively. That'll wait this amount of time, and if the test doesn't complete by then, it'll interrupt it. It actually spawns a separate thread, which it will interrupt if necessary. And then there's the method called a getSync. And I can get the number and the assignments, and I can make sure the message is success, and get the number should be equal to the size of the assignments, and I could do all the rest of this as well. And if you're interested, I could show you, but the truth is if I just run this, you'll see now I'm logging the number of people and then each person aboard each station using the logger. Each craft, actually, in this case it's the ISS. So this is a new repository that I just added, which I called Astro something or other. It's in my GitHub repository. I'll show it to you in a minute. But that's now there. Now I can't leave that alone because I also, in my Java 9 repo, that's the Java 8 one. Okay, here's the Java 9 repo. I had a version of an HTTP client project which uses the site ICNDB. You ever heard of ICNDB? Here, icndb.com, which is the Internet Chuck Norris database. It's a database of Chuck Norris jokes. And they have a RESTful API, and you could just call it. Now, the thing is that some of these are not really suitable for public consumption. So I have to put a filter on here where, by the way, I could change the first and last name of the hero. And like here, time waits for no man unless that man is John Doe as opposed to Chuck Norris. You know, that was my favorite, most interesting man in the world commercial was if opportunity knocks and he's not home, opportunity waits. You know, I like that one. But at any rate, you don't just fetch a random joke. Instead, I put in a limiting category where I limit it to the nerdy category. Okay? Now, with that in mind, here is my joke client test. Again, just going to use the JSON mechanism. So I made the joke client, which is here. Let me show you the client. There's the HTTP client with the builder. There's JSON. And then here I'm plugging in a first name and a last name. And I needed a first name and a last name, so of course I picked Pratik Patel, who's not here, so I had to use him. But this is all building the request and then calling it synchronously, calling it asynchronously, and parsing the joke. And you could see also here, there's my hero's first name and last name. When I run these, you'll see that, let's see, Pratik Patel's programs occupy 150% of CPU even when they're not executing. Yeah, or Pratik Patel doesn't need garbage collection because he doesn't call dispose, he calls dropkick. Well, that's okay. I mean, but there's a bunch of decent ones, and this is all in the Java 9 repository if you want. Now, again, I'm running it under 11, but it's just an example of how to use that HTTP client. Okay, a couple of miscellaneous things. The underscore character is now reserved. You can't make a variable that's a single underscore anymore. I didn't know you could before, but now you really can't. You can use two underscores. You could do underscore ABC, that's fine. But a single underscore, no. And I suspect that's going to be used in something that's scheduled for 12, which is the pattern matching API. So I suspect that's going to be a wildcard there, but I don't know for sure. The applet API, again, is gone. Java-C drops support for older versions of Java. The browser plugin's gone. There's a stack walking API, too. I've never needed that either, but if you generate an exception, you can capture the stack and then work your way through it programmatically now. They have a walker class or stack walker class and all sorts of methods there. Again, something I've never used, but it might be of some interest to somebody. You know, it might be helpful. Again, the search box and the Java docs, and most of the big changes that have happened since 9 have been under the hood, performance related. Garbage collectors have gotten much better. They have parallel garbage collection now. They have a new garbage collector in 11, which is supposed to be even more efficient. Not stuff that changes my day-to-day work, certainly doesn't change how I write code, but might affect the behavior ultimately. So, Java 8 was the big one. Moving to streams and lambdas and method references, that's a whole different paradigm for coding. Java 9, the big issue was the modules, okay, Jigsaw and all of that stuff, and we'll be paying for that decision for years, okay? But there's also JShell and lots of little miscellaneous things to make life a little easier. I didn't even show you, there's a bunch of extra methods on stream and on optional, you know, there's a lot of extra filtering mechanisms. There's a take while and a drop while where you could take while a predicate is true or drop while one isn't true. You know, there's a lot of nice features in there. But again, that's just additions to what we already know. In Java 10, the big addition was the local variable type inference, which is not a big change. And in 11, they basically have nothing. In fact, I actually went and found a web page. Where was it? This one, an article at DZone, which was talking about getting ready for Java 11, and they said, okay, oh, yeah, you can use local variable syntax on a lambda parameter. You can now actually write, in parentheses, var a on a lambda parameter, which you normally leave without a parameter at all, because it's inferred. Why would you want to put var on there? In case you needed to add an annotation to it. You can add it not null, for example, on there. That's the only use case they could even mention, that could even come up with. And then, of course, we have this new HTTP client. They upgraded Unicode. They upgraded the security transport layer. You can launch the single file source code programs. They made the flight recorder. They extracted it, pardon me, from Oracle and gave it away. It's an open source project and lots of garbage collection stuff, and that's it. See, so the real challenge you'll have will be going from 8 to 9 if you need to deal with modules. If you don't need to deal with modules, you're just going to use them, you should be fine. And then from 9 to 10 to 11 is trivial. Really easy. And expect 11 out in the next couple of weeks, and then 12 6 months from now. That'll be out in, what is that, March? You know, and then 13 6 months after that. 11 is a long-term support release, however. It will have security and other patches available for at least 3 years. And of course, Java 8 will have patches available till January. And if you're willing to pay for these things, you can have it longer than that. All right, there's the big picture. I think that's everything I had in the slides. I gave you the GitHub repositories. The only one I didn't mention, wait a minute, where's my GitHub repo here? Yeah, I called that Astronomy 1 HTTP client demo. The others were Java _8 recipes and 9 recipes. This is that Astronomy 1 is the HTTP client demo for Java 11. Got a little README in it that explains that. That's all it is. And I've got a Gradle build file for all these things. I will be happy to hang out and answer any questions, comments, words of wisdom. If you heard any good jokes, I need those, as you can tell. Actually, one is, if you put 1,000,000 monkeys in front of 1,000,000 typewriters, eventually they will type a Java program, and the rest will be Perl programs. I thought that was a good one. Okay. So thank you very much for coming. Any questions about anything? I'll get those slides to, should I send them to Pratik or send them to you? I'll send them to one or both of you, what the heck. So that'll come very soon.
So regarding the licensing thing, you're saying the support structure for Java 8 is going away in January, right?
That's right. Java 8 is officially the end of life in January. Although, again, if you're willing to pay for these things, there's ways to get around that.
So the Java 11 means the long-term support.
Right.
So what does it mean? Long-term support till 12 comes on?
No. 3 years minimum, and maybe longer. So Java 11 is going to have bug fixes and security fixes released at least until Java 17. So 6 versions, 3 years, and possibly longer depending on what's going on. Okay, so they're expecting everybody who's waited to upgrade for 9 or 10 to suddenly say, okay, I have to go with 11. And what they're doing to push that again is that you can use Java 11, the Oracle JVM, in development mode and in testing mode, but if you use it in production, you have to pay for it. And the alternative is to go to the OpenJDK project, which is then free, but they'll only release fixes for the current version of Java, whatever that is. And then there's a lot of effort going around with a lot of competitors and a lot of choices. And again, there's a Java Champions link that they wrote out a whole big document on all of this.
Yeah, so
You happen to remember where it is?
Twitter is your friend, and you really should follow @Java on Twitter, because that handle reposts a whole bunch of stuff from not just the core product team at Oracle on Java, but also the Java champions who are,
Java is still free. Here it is. It's in lots of places. Here's the Medium post. And there's an original Google Doc, and they have all the short answers and the longer pieces here. So just Google Java is still free, and you'll find out the best of everybody's knowledge right now, right? There's a BCL, the binary control license or something like that, as opposed to, you get into the depths of this stuff, and I still find it very confusing.
So Java is undergoing so many version changes. What are the implications of the downstream Java JVM dependent products like Groovy, Kotlin, Scala, and all those?
Well, they have to deal with it. That's basically it. I mean, Groovy, that's why you get that illegal access exception, or not exception, but illegal access warning whenever you run a Gradle build on Java 10 or 11, because Groovy uses reflection to cache some things to make it go a lot faster, and that crosses a reflection boundary, and right now they just warn about that and try to scare everybody and say that's going to be an error. Well, it's not an error in 9, 10, or 11. By the time it is an error, Groovy will have a workaround for it. But yes, each of these dependent languages is having to deal with this upgrade. Now, again, one way to help think about this that'll simplify your life, don't think of the major number as semantic versioning like we're used to. Usually when they change a major number, that means breaking changes. You see, these changes are so tiny that they could have made it Java 9, arguably a change, and then 9.1 and 9.2, or maybe 9.1.1 even. You know, these are very tiny changes. And if you think of it that way, Java's always been doing that, releasing a little new build and a little change. As long as these changes are relatively small, and the big one you'll deal with is modules. After that, life should be very simple, in my opinion.
Wasn't there some huge discussion?
Try again.
Wasn't there some huge discussion around the namings of the versions a while back?
Yeah, they were trying to pick a year for the names. They're going to do like 2018.9, and then they're going to make 2019.3 for the next one. And a lot of people hated that, and now they went to these major numbers, which I find misleading because people think, I mean, you remember how big a change it was to go from 1.7 to 8. Well, 8 to 9, you got one issue, and you don't even have to deal with that issue. Like I say, I run all my Java 8 code on Java 11 without any changes, unless they remove the modules. Then I need to add those modules back into my Gradle build, the dependencies. Other than that, everything's been pretty easy.
So, you know, even though the core product team, the Java team at Oracle does the heavy lifting here, the JCP is still very, very, very important, and that's a community-driven effort. Mm-hmm. So the community drives this language.
Does that help any? Yeah. I'm an Oracle dev champion. I shouldn't say bad things about Oracle, should I?
Yes, you should.
Yeah, okay. Yes, sir.
So even if we use the Oracle's JDK 11 in production, do we have to pay?
That's, in principle, I believe that's correct. So instead, just use the Open JDK version in production, and it's free. Or there are competitors now. There's the Adopt Open JDK project, too. There's going to be a lot of them. Again, take a look at this document. Everything's in there. Pardon me? Azul. Yeah, Azul is one of the major competitors, AZUL. They've been producing JDKs forever. They are highly optimized.
Yeah, so does IBM, right?
IBM has their own one also. They all adhere to the same TCK. They all pass the tests. So they all should be fine, and there'll be lots of competitors around this. But Oracle's claiming this is how it's always been, that if you wanted all the bug fixes and everything, you had to pay for all that after the end of life anyway. You know, okay, interpret it however you like. And again, most of the answers, well, the answers such as they are here. When this actually happens, we'll see how the community reacts.
So this isn't, you know, because I work at Oracle, I know some of this stuff. And because I'm in the community, I can just surmise some of this stuff. This is not like a revenue model for Oracle, charging for support. Mm-hmm. Because in the grand scheme of Oracle, Java really doesn't bring in that much revenue. So it isn't like, oh, all of a sudden Oracle's going to make $1 billion more because of this. They're not.
And people have in the past taken Oracle patches and applied them to the Open JDK project. I mean, it's very likely whatever Oracle does will, I mean, Red Hat's famous for that, taking the Oracle patches and applying it to the open source version of Java. I don't see any reason that won't continue. It probably will. Just, you're going to have choices to make in the future. That's the bottom line.
So does Open JDK versioning is same as Oracle?
Yes, the versioning will be the same. The version numbers, everything will match. They'll iterate around documentation and discussions and things like that. Azul, I think, is doing the same thing. You know, right now they're putting a dash after it and putting in their own information like EA or something. But I expect all of them to version together.
So how much support you can get it for Java 8 after January?
You cannot, okay, as far as I know, you cannot get bug fixes or security fixes on Java 8 after January of next year. But that being said, I always hear about companies saying, yeah, well, if you pay enough, you can. But I honestly don't know. So the principle, the argument is end of life, January 2019, at which point, although there's some extensions on that too, right? But at any rate, all the new work will be on, 12 by that point.
Based on the title of this talk, at least the email and stuff, where do you see Java in the next 5 to 8 years?
Where do I see the next 5 to 8 years? Okay, first of all, I never guess beyond 2 years because I've been wrong too many times. I don't know. I think that the fact that they've moved to this rapid release schedule means they're trying to innovate around the JDK and bring in new changes quickly and get them into the marketplace. And then they'll decide based on the marketplace whether to keep them or not or what to innovate beyond that. Some of the people that are in charge of all this, I know, like Brian Getz, that's the guy I want making those decisions. I mean, he really is that good, and he's very careful about not introducing things that cause sweeping, breaking changes in general. I think that Java has been revitalized, especially with Java 8 and above, and I think and certainly in the next 2 to 3 years, I think it's going to be every bit as powerful and as pervasive as it is now. I really do believe that. I don't know how this module system thing's going to play. I'm worried about that myself. But we'll see. That I don't know about. But again, we got the rise of the alternative languages. Although let's be honest about that. If you like Groovy or Scala or Kotlin or Clojure, you put all the developers from all of those together, that's less than 5% of all Java developers. Okay? So it's a good group, you know, they're the good people, right? There's a lot of good stuff in there, but we're not talking a lot. Now, Android may change that for Kotlin. Okay, Android's the killer app for Kotlin. People are adopting Kotlin to write Android. You know, they say, what is it, 75% of all Kotlin developers are working on Android apps. We'll see if that breaks into Java proper. Right now, it's partly just stealing people from Scala as well, you know. So, and Groovy's still growing. Groovy 3 will be out by the end of the year, and that's an Apache project and doing very well. So I still like Groovy, and I've learned Kotlin because of Android and a little bit because of Gradle. I know it may not be what you wanted, that's the best I got. Right now. Anything else? Anything not involving licensing? Yeah, I know. I totally get that.
So to those points, we're trying to get somebody from the Oracle Core Java team here in November. It could be Brian Getz or it could be Don Smith. We don't know yet, but one of those guys is going to come out and talk about this more. And you can ask all your licensing questions then, and all your FIDO questions is then. So actually that'd be a really good one. Bear that in mind. Whatever the date is in October, 3rd Tuesday, you guys know, it will be somebody from the Oracle core product, Java product team.
But those core team members, a lot of them, were involved in putting together this document. This is the medium version, but there's versions on many places. It's going to be one in InfoQ. It's all around. This is the closest thing we have to a definitive answer until Oracle decides to publish something official beyond this.
Real quick question, as far as common features that really like null safety, do you see that coming to Java?
Kotlin's biggest appeal is the null safety, as you mentioned, also the immutability, you know, that you can't modify anything. You get all these immutable objects or unmodifiable objects. A lot of type safety, everything's statically typed. They also have static binding by default, which I'm not wild about. You can't override any methods unless you open them, you know. But they have gone to the extreme without incurring the complexity of Scala. I see them as a competitor to Scala personally. Can I give my joke? You're not recording anymore, are you? Or you still are? All right. I'm going to get myself in trouble with this. I appeared on the Talking Kotlin podcast with Hadi Hariri, and I wasn't brave enough to say this out loud on the podcast, but after it was over, I told Hadi that to me, Kotlin looked like Groovy for dummies. And he laughed and he said, well, he thought of Kotlin as, Groovy for cowards. That's what I called it, Groovy for cowards. I'm so afraid I'm going to get a null pointer exception. I'm so afraid something's going to be null. I'm terrified. Whereas he called it Scala for dummies, you know, that you didn't have the complexity there. And of course, the giant irony here, everybody's talking about static typing being so critical. It's the only way to stay ahead of problems. And the two of the most dominant programming languages in our industry right now are JavaScript, my condolences, and Python, both of which are dynamically typed. So something's works over there, but regardless, I think Kotlin has had a huge boost because of Android. I think it has a lot of the nice features that it learned from Groovy and Scala, by the way, and that combination will lead to significant growth. Now, is significant growth 5% of the programming market? Is it 20% of the programming market? Ask again in a year, we'll know a lot better. But it's, I think it is worth your time if you're interested. I think it's a good one. Anything else? Have to come back and talk about Kotlin, I guess.
Okay, thanks very much.
Oh, thank you.